NASA's Deep Space Network just went silent. For 12 seconds, every telescope tuned to one frequency, and every instrument recorded the same impossible spike. No interference, no static, just a clear, deliberate pulse echoing across half the planet. Technicians called it a glitch, physicists called it impossible, but if the universe ever decided to speak, this was the moment it chose to whisper back. There are moments when physics trembles, when the equations we trust begin to shake beneath something we can't quite explain. Every generation of scientists faces one of these moments, a whisper from the cosmos that sounds less like chaos and more like intention. Space is never silent. It hums with background radiation, the fading echo of creation itself. But this was different. The signal that reached us wasn't random noise. It carried rhythm, precision, and structure. For decades, we've listened for voices among the stars, expecting only silence in return. Yet here, in the static between worlds, something answered. Softly, deliberately, impossibly. And so the question shifted. We weren't asking if the universe could speak anymore. We were asking what it just said. Because this time, the whisper wasn't background radiation. It was a call. In July of 2025, what began as a faint glimmer on a wide-field survey image would soon unravel one of the strangest chapters in modern astronomy. At first, it was nothing, just a dim, unremarkable speck sliding across the cosmic backdrop, a point of light among billions. But over the next several nights, that speck refused to behave like anything cataloged before. Its trajectory didn't curve along the predictable pathways of asteroids or comets. It cut cleanly through them, on a line that came from nowhere we recognized. When astronomers plotted its motion backward, the numbers told a startling story. This object hadn't emerged from our asteroid belt or the distant Kuiper frontier or even the frozen shell of the Oort cloud. Its orbit wasn't closed, it was open, a hyperbolic path, meaning one thing only. It came from beyond our sun's gravitational reach, from the deep between stars. We named it 3I/Atlas, marking it as the third interstellar visitor ever recorded. The first, Oumuamua, arrived in 2017, an enigma of acceleration and shape. The second, Borisov, in 2019, more familiar, yet still impossibly fast. But this one was different. 3I/Atlas is moving at roughly 152,000 miles per hour, nearly 5 times faster than any typical comet in our neighborhood. Its trajectory cuts through our solar plane like a blade of light. Too quick to be captured, too steady to be dismissed. And what's most extraordinary is not where it's going, but where it came from. Tracing its path across time suggests a birth around another star, perhaps one long dead, its planets scattered, its system reduced to memory. So what exactly are we watching? A fragment of another sun's story now passing through ours. Then, without warning, the instruments listening to 3I/Atlas began to react. It started as a faint spike, a whisper across multiple observatories, small enough that most teams dismissed it as background interference. But within seconds, that whisper became a synchronized pulse. From Canberra to Madrid, from the Deep Space Network in California to the Atacama Array in Chile, the same frequency emerged, narrow, focused, repeating in perfect intervals. Not a solar flare, not the usual cosmic hiss of radiation. Something deliberate. Operators ran diagnostics. Systems were clean. Atmospheric distortion? Impossible. Weather patterns were clear. Equipment error? Ruled out by identical readings across 4 continents. Even our own sun, under constant observation, showed no flare activity that could mimic such a structured emission. And yet, there it was, a pattern. 3 bursts, a pause, then 2. Always the same spacing, the same modulation curve. It didn't carry information we could decode. No recognizable data stream. But it had the unmistakable fingerprint of design. For 12 seconds, the universe seemed to speak in a language of precision, and then silence. Radio astronomers compared timestamps. The burst occurred exactly as 3I/Atlas crossed a key magnetic field boundary near its projected perihelion arc. The alignment was mathematically perfect down to the millisecond. Coincidence perhaps, but when the readings were replayed and cross-referenced, something stranger appeared. The signal intensity fluctuated in correlation with Earth's rotation, as if the source adjusted moment to moment to keep us within range. That single detail changed everything. For the first time, an object from another star had not just reflected our light. It had responded to our presence. It spoke once, and only once. A 12-second statement written in radio waves across half a planet. Once could be chance, twice would mean intent. If the signal was strange, what followed made it undeniable. This object wasn't behaving like anything nature casually assembles. Let's start with reflectivity. Every known comet in our catalog is a dirty snowball, rough, pitted, and chaotic. They scatter sunlight unevenly, their brightness flickering as irregular surfaces catch and lose reflection. But when 3I/Atlas came into view under the Webb Space Telescope, something astonishing appeared in the data. Its surface wasn't dull, it was brilliant, reflecting light with uniform intensity across multiple wavelengths. To achieve that, the exterior would need to be extraordinarily smooth, as if polished, as if manufactured. The photons bounced off it with mechanical precision, the way they would from a refined alloy, not a natural rock. Then came the rotation anomaly. Comets tumble. They spin unevenly, destabilized by jets of gas or ancient collisions. 3I/Atlas, however, rotated with exact rhythm, a constant interval, unwavering like a gyroscope. No wobble, no drift. Its orientation relative to Earth stayed so consistent that even the smallest change in angle could be predicted to the second. Natural objects don't do that. Machines do. The thermal readings deepened the mystery. Webb's infrared sensors revealed one hemisphere glowing hotter than the other, persistently over days. Not because of solar heating, which should rotate and distribute, but as though the object itself regulated temperature internally. A vessel with radiators, a system balancing its own heat. No comet has ever shown that kind of self-stabilizing behavior. Then came composition. Spectroscopic analysis detected immense carbon dioxide output, 10 times higher than expected for its size, paired with massive nickel traces, but a near total absence of iron. That alone breaks every model of cometary chemistry. And among those readings lurked something even more unnerving: organized carbon molecules, complex, patterned, non-random. Structures nature can form, but only under conditions we usually associate with biological or engineered processes. Next, density and internal structure. By studying light curve oscillations, researchers could infer the object's internal consistency, and what they found wasn't solid. 3I/Atlas resonated as though hollow, a shell enclosing empty space. Natural bodies don't form cavities like that. Gravity compresses them into dense cores. Yet here we have something layered, compartmentalized, like panels. It's as if it was built, not born. Finally, the trajectory shifts, the anomaly that made every astrophysicist sit forward in silence. The object adjusted its course in increments so small they were almost invisible, millimeters per second, but always in alignment with optimal Earth-based viewing windows. Every time our telescopes have the clearest line of sight, its orientation corrected. When visibility waned, the movement stopped. Solar radiation can nudge objects. Outgassing can cause drifts, but not like this, not with timing this deliberate. By the end of the observation cycle, the data painted a portrait of impossible precision. Reflectivity like metal, rotation like clockwork, thermal regulation like a system under control, composition that defied geology, and motion that seemed aware it was being watched. And so researchers found themselves trapped between two explanations, both unthinkable. Either nature just learned precision on a level it has never displayed before, or something else built it. Then almost overnight, the flow of information stopped. NASA's open access telemetry logs, normally public by default, were quietly pulled. The European Space Agency's observation schedules disappeared from public view. And at the Jet Propulsion Laboratory, an institution built on collaboration and transparency, servers hosting Atlas data were taken offline without explanation. Requests for access were denied, collaborators reassigned, conferences canceled. Freedom of information filings began circulating among independent astronomers. What came back were documents buried in redactions, whole pages replaced with black bars and a single phrase repeated like a warning: national security classification in effect. National security over a comet? That's when the whispers began. Teams that had been analyzing Webb's spectroscopic data, the same readings showing those impossible molecular patterns, were suddenly restructured. Some of the most outspoken researchers went silent. Others hinted at being told to stop. The official line blamed data inconsistencies and processing errors, but the timing was too perfect. The blackout began the very week Webb's instruments recorded the highest resolution chemical scan of 3I/Atlas data that, according to internal memos, contained non-referential spectra, meaning the molecular fingerprints didn't match anything in our known cosmic library. And that dataset, those final unfiltered spectra, was never seen again. NASA's internal database now lists the record as archived pending review. No one outside the agency has clearance to view it. ESA followed suit within days. The international collaboration that had defined interstellar research for a decade fractured almost instantly. You can't help but ask the question scientists aren't supposed to ask. What could possibly justify hiding light readings from a comet? The answer perhaps lies in what those last observations revealed, something so far beyond the familiar that even acknowledging it might unravel the narrative of what we believe space to be. Because somewhere between the final photon and the locked file, the story of 3I/Atlas stopped being about science and started being about control. Just when the world began to settle into silence, when the blackout became the new normal, it happened again. In the early hours of October 17th, deep space listening arrays in South Africa, Chile, and Western Australia independently logged a faint but unmistakably structured burst. The pattern was weaker this time, buried beneath cosmic noise, but when the data was synchronized, it aligned too precisely to ignore. The same frequency range and the same narrow bandwidth, the same spacing between pulses, but with one crucial difference: variation. The new signal wasn't identical to the first. The interval shifted slightly as if following the rhythm of a previous transmission, like an echo adjusting to feedback. And this time, the timing wasn't random. It coincided with the exact window when 3I/Atlas had moved behind the Sun, completely hidden from every optical telescope on Earth. That shouldn't be possible. When the object was visually unobservable, when no sunlight could reflect from its surface, the radio silence should have been absolute. Yet the burst came through, cutting straight through solar interference, precise to the microsecond. By dawn, the network chatter among observatories was frantic. NASA channels, which had been dormant for weeks, showed encrypted pings. Independent operators found their feeds throttled. But before any confirmation could be made, the signal faded like the first one, abruptly and completely. Analysts compared the two bursts side by side, the first strong and commanding, the second faint, more complex, like a pattern continuing from a starting point we'd already missed. And that's when the interpretation began to shift. If the first emission was a call, a signal cast outward into the dark, then this might be the reply. Once could be coincidence, twice becomes a conversation, and somewhere out there beyond the reach of our instruments, 3I/Atlas may not be moving alone. Patterns are the foundation of science. When something happens once, it's an anomaly. Twice, it's a curiosity. 3 times, it becomes data. In 2017, we encountered our first interstellar visitor, Oumuamua. It arrived silently, moving in ways no rock or ice body ever should, accelerating as though nudged by invisible hands. For months, we argued over its shape, its speed, its impossible light curve. It was a test of detection. Could we even recognize something that didn't fit our models? Then in 2019 came 2I/Borisov. This one looked more conventional, a tail, a coma, all the hallmarks of a comet. But its composition was off the charts. Cyanides, carbon chains, and molecular patterns we'd never cataloged before. Borisov became a test of chemistry. Could we identify something chemically alien yet still natural? Now, 3I/Atlas. Faster, stranger, brighter. It arrived not just to be seen or analyzed, but to be interpreted. Because this time, light and radio, structure and silence, geometry and signal, they all seem connected. It's as though the object doesn't just exist in our frame of reference. It reacts to it. Across research circles, a quiet hypothesis is forming, one that's spoken carefully, almost reluctantly. What if these aren't random fragments wandering through our solar system? What if they're part of a sequence, each one escalating the mystery, each demanding a higher level of observation, computation, and thought? First, they tested our eyes, then our instruments, now our understanding. Perhaps these objects are not visitors at all, but evaluations. Not communication in the linguistic sense, but assessment, measurement. A way to gauge whether a young emerging civilization has reached the threshold of awareness required to see what's in front of it, and yet the scientist in me insists on restraint. There are natural explanations that can account for much of what we've seen: exotic outgassing, electromagnetic interactions, plasma reflections. These theories hold weight, but still, the sequence, the precision, the timing, they whisper of design. Maybe the truth isn't that we're being contacted. Maybe it's simpler and far more profound. Maybe we're being noticed. In the first three, I/Atlas is entirely natural, a rogue fragment of some distant dying star system sculpted by forces we barely understand. Its perfect symmetry, its heat regulation, its strange chemistry, each may have a natural explanation waiting just beyond the horizon of current physics. If that's true, it means nature is far more creative, far more capable of precision than we ever imagined. We would be forced to rewrite the textbooks, to redefine what's possible in the chaos of cosmic formation. But in the second future, 3I/Atlas isn't natural at all. It's deliberate, constructed, a message or perhaps a mirror, something placed to be seen once we develop the tools to notice. If that's true, then we're not witnessing a scientific anomaly. We're witnessing the beginning of contact. Either outcome would reshape everything we know. One rewrites the laws of physics. The other rewrites the story of humanity, and that's the beauty and the terror of this moment. Because until we know which future we're in, we stand suspended between them, staring into the unknown, listening for another whisper in the static. Either way, the silence between stars feels smaller now. Science was never meant to make us comfortable. It was meant to make us brave. Every discovery, every anomaly, every unexplainable flicker in the dark is a challenge, not to our faith, but to our imagination, because courage in science isn't found in the answers we hold. It's found in the questions we're still willing to ask. 3. I/Atlas may be nothing more than a wanderer of frozen gas and dust, or it may be something infinitely more deliberate. But either way, it has forced us to look up again, to confront the vastness not as empty, but alive with possibility. Perhaps it's a question written in light, and we've only just learned how to read it. If this was the first message, wait until you see what came next.